Our next tool for review is the rotary table. This is a horizontal vertical rotary table, a very precise instrument. We showed you the spin index fixture earlier, and it'll get you by for most machine shop applications, again depending upon the accuracy. But when we need extreme accuracy, the rotary table comes into play. In order to set your rotary table up, first we need to clean our bed off, make sure that the bottom of the rotary table is free of chips and burrs, and then we're going to mount that directly to the table. We are going to dial indicate the spindle over the spindle hole in the rotary table, and we can use our coax indicator to achieve that in just a few seconds. The rotary table is ideal for doing hole patterns, milling circles, cams, ovals, things of this nature where complex milling operations come into play. Once we've dial indicated the spindle directly over the spindle of the rotary table, then we simply offset in the X or Y axis for a specific diameter hole pattern and begin to advance the hand wheel, breaking up that hole pattern in a number of degrees depending upon the number of holes in a 360-degree circle. This particular rotary table is set up in minutes and degrees. We have 360 degrees in a circle. We have 60 minutes in a degree and 60 seconds in a minute. So you can see with a precision rotary table just how fine we're breaking that circle up in terms of its rotational degree arcs. If we look closely now at the dial and we were ready to start a hole pattern, we have 10 minutes, 20 minutes, 30 minutes, 40 minutes, 50 minutes, 60 minutes, and 1 degree in the rotation of our hand wheel. We've got some little lock brakes on the sides of the rotary table. So let's say that we were doing a 10-hole pattern and we needed to index those holes every 36 degrees. We would simply advance the hand wheel the appropriate number of revolutions in order to go 36 degrees. We're going to put our little brakes, if you will, on. These are locking gibs on the rotary table. Drill, countersink, tap our hole, loosen them up, continue to index around to our next 36-degree hole spacing, repeat the process for a total of 10 holes or 360 degrees. The repeatability and the accuracy of a rotary table is nothing short of phenomenal. Turned in the vertical position, we can mount a chuck through the spindle hole. This particular spindle hole has a Morse taper. We'll show you as an example by inserting the Albrecht chuck in its place. Just visualize this as a lathe chuck where we can grab and hold parts in a vertical or horizontal position for machining. Now let's say that we've got a block and we need to machine a radius or a circle or do a hole pattern in it. We would simply set our block on the rotary table. Again, keep in mind we've indicated the spindle directly over the spindle hole in the rotary table. We can take our step clamps, hold our workpiece to the bed, index off the appropriate amount depending upon the diameter of the hole pattern, and then proceed to rotate and machine. Anytime that we are machining on a rotary table where we're using an end mill to cut a circle or cut a cam, our direction of rotation is such that we want the cutter to be conventional mill cutting. We don't want to be climb cutting around trying to suck that cutter or the worm feed of the rotary table into the cutter. We always rotate the table in the direction so we can use a conventional milling process. That's very, very important. That allows our rotary table to last a long time, prevents injury to the workpiece or ourself if we happen to suck the part out or break a cutter trying to climb cut on the rotary table. All right, that pretty well covers the rotary table. I'm going to go ahead and flip it up into the vertical position so you can get a perspective again of the versatility involved in a rotary table. Remember we talked earlier about our spacers on the bottom of our mill vise. Well, the same thing has been done here on the rotary table, so we would simply invert this, line it up in the T-slot, pull it to one side where both of these rail edges align, and that's going to pretty well align it. So let's go ahead and give that a try. Keep in mind rotary tables are quite heavy, So make sure you have some eggs for breakfast or Wheaties in order to hoist that around. Okay, there we are in a vertical position. We can continue the rotation of our part. Imagine we have a drill chuck in place or a lathe chuck. We want to continue to advance those parts, drilling, tapping a hole pattern, machining a groove, a cam, whatever the case may be. So it's a very versatile application. Again, we would lock down our gibs anytime that we were to make a drilling or milling operation, holding our workpiece very rigid.